What are you doing?
Miss Wright.
Whoa!
Rachel, I just said to be quiet and you started talking. Today is Wednesday, February 12th, 2020. The answers are on the board. Cameron says, why are they like that? I said, because that's how they are in the book, so I put them on the board like they are in the book. 4, 5, 6, 7. Check your answers. If you don't have those, you are delinquent. If you weren't here yesterday, if you weren't here yesterday and you didn't watch the video because you just couldn't. You just couldn't fit it into your... know that, without talking, know that you're responsible for 4 through 18 on pages 356 and 357. We can't stop the train and do the whole lesson again. Here's the lesson in a nutshell. It's simple probability. If you remember, even back in 5th grade, I have a coin. How many sides are on the coin? 2. The possibilities are always in the denominator. There's 2 sides on the coin. What's the chances? What's the probability that I'm going to have it land heads up? How many heads are on the coin? 1. So it's 1 over 2. The probability is a half. We can change that to a percent and call it 50%. Probability is always between 0 and 1. Because if there was no chance of something happening, it would be 0 over 2. 0%. And if there was a definite, guaranteed certainty it would happen, it would be 2 over 2. For instance, what's the chances it's going to land heads up or tails up? 2 out of 2. There's 2 possibilities, and we're using them both. So 2 over 2 equals, and 1 equals what percent? Percent. So things in life are either more likely or you're imagining the scale being on there when I keep doing this. Things in life are either impossible, certain, I'm writing sloppy because I'm saying the words. They're either more likely, which we would say probable, or less likely, and we would say improbable. Right down the middle is neither, right? It's 50-50, 50%, because it's between 0 and 1. So right down the middle would be a half. So we can assign percents. So the other example we used in class yesterday was the number cube. How many numbers are on this number cube? Different numbers, 6, right? So what's the probability? What's the chances that I'm going to roll 1? How many total chances are there? 6. It always goes in the denominator. What's going to be my numerator? The probability I'm going to roll 1. 1. There's only one on here. 1/6. What's the probability I'm going to roll an even number?
3.
2, 4, 6. 3 out of 6, or 1/2, or 50%. You catch that? That's all yesterday was. Simple probability. The hardest part yesterday, for those that were here, was maybe 15 through 18. Because 15 through 18 puts a little twist on it. They have 120 marbles in a bag, and they tell you at the bottom on their chart that when someone went in and pulled marbles out of the bag, they reached in 15 times. How do I know that? Because they reached in and pulled out a red one 7 times. You're looking at the bottom, 356. Where's your book? They pulled out a yellow one 3 times, and they pulled out a green one 5 times. If you add up all of those events, it adds up to 15. So, for number 15, if they pulled out 3 yellow, they reached in there 15 times, so there was 15 different events of pulling something out. And how many were yellow? 3. How many total marbles are in the bag?
120.
They didn't reach in 120 times, they only reached in 15. So we could expect, the book says, what would you predict, I think? What's the book say? Estimate. Estimate. We could expect, we could predict, we could estimate that if we were to reach in there 120 times, how many yellows would we pull out? So we set up a, what's that called? Start with a P, equal fractions? Proportion. We set up a proportion, and what's missing here is what we would estimate how many yellow marbles are in that bag, based on the fact that we reached in 15 times and pulled out 3. Do we know for sure how many yellow marbles are in there? No. We're working with probability. There's probably 24. What if we did experimental probability and we emptied them all out and found out there was 22? Did probability work pretty good? Yeah. Wasn't exact, but we can estimate there would be 24 here because 3 times 120 is 360 divided by 15 gives us 24. Or, if you're really good with your math facts, 15 times 8 gives you 120, so 3 times 8 gives you 24. That's how we get our 24. Kara, quick.
So,
I did say at the beginning I can't do the whole lesson again, didn't I? We got to keep moving. Go ahead.
what is that? How did, so, when you do that, it wouldn't really be fair because you could have just, like, it depends on where you pick. It depends how many marbles there are. What? I'm confused about
I'm not sure either.
Like if you pick in, you might have, there might be 54 yellow ones in there and 7 red ones and 5 green ones, and you could pick out 3 yellow, 7 red.
Okay, when you're saying not fair, listen.
No, it's not.
Shh.
I'm not.
When you're saying not fair, it's not perfect. We don't know that there's exactly 24 yellow marbles. We are estimating based on our 15 events, 3 were yellow, so we're estimating there'd be 24. You might be right, there might be 54. It might have been a really weird example of, man, we just kept picking out yellow at random. That was a strange event. That would be what's called an outlier. That would be like something that doesn't fit the model for probability. Now, okay, let's relate it to weather. Right now, they're saying there's a, say they're saying there's an 80% chance of snow tonight. They base that on all the events that they've studied over the last 150 years when the atmosphere is like it is today and the temperature and the pressure and all that stuff is like it is today. 80% of the time, we're going to get snow. Well, it might happen that we don't get any snow. It might happen that we don't get any rain. But we're probably going to based on all the events we've studied. Does that make sense, Kara? Sometimes it just doesn't work. But most of the time, here's the thing. Here's the time it works. It doesn't, you'd be like, because when I don't want to get too deep into this, but when they take polls, have you ever heard of political polls like, hey, 48% say that they're going to vote for this person? Okay. Do they know that for a fact?
No.
They only call about 1,000 people, and millions are going to vote. Now, they don't always get that right either, but you know what? They don't get it totally wrong. You know what I'm saying? Like, they'll call 1,000 people, and 480 say they're going to vote for this person. What ends up, that's 48%. It ends up that person gets 45% of the vote. Well, they weren't exactly right, but they were pretty close. Right? 86% didn't vote for that person. They got pretty close. And that's just, listen, that's just the way of it. That's how statistics probability works.
But like, let's say there's like, well, there in real life, but like you want to get something and you get tickets and you put them in there, and there's one person that put in.
Like in 5th grade, I said, how many times it go against the odds? Remember the times when I would pick a name and it'd be someone that wasn't here? Do you remember those days?
Yeah.
Be like, or I'm looking, I want to make sure it's even, so I want to pick a girl this time, and I pick like 4 straight boys, whatever. Right. There's things that happen that don't go according to statistics, but most of the time it does. Anyway, while you're trying to figure all that out, know this. Based on theoretical probability. Theoretical. See, even in your question, Kara, they've answered it for you. Because what kind of probability is it called? theoretical.
Why do they even have it if they know it's not like it's not good? Like, why do they even have that? If it might not, like,
All right. Do you understand how we did it? Set up a proportion. If 3 out of 15 were yellow, then Bella says, I can predict 24 out of 120 would be yellow. That's it. All right, continuing on. Let's talk about, toes. Page 357. In a survey of 896 people, 409 responded that their second toe is longer than their big toe. We're not all taking our shoes off right now, and maybe you haven't studied your feet very much before, but some of you might know if your second toe is longer than your big toe. 409 out of 896. I'm looking around at faces of people's eyes, and they're like trying to picture their feet right now.
No.
What's the probability, Kiara, if they surveyed 896 people? Kiara, they did not survey 350 million people. They did not survey 7+ billion people. They surveyed 896 people, and out of those 896, 409 said their second toe is longer than their big toe. So, what is the probability that at random we choose a person and check their feet and their second toe is longer? How do we figure it out? Anybody? Hello? What's the total people they surveyed? Where's that go? Denominator. The total always goes in the denominator. What event are we looking for right now? We're looking for second toe is longer. How many people responded their second toe is longer? 409. How do I find percentage? There's two ways. Remember, I could set this equal to 100. Why bother doing that? You find percentage, same as a fraction. What part is this number of that one? 409 divided by 896. It takes a while, but if you figured that out, you should be doing that now. You were just waiting for me to give you the answer.
No.
Yeah.
I would never do that.
Okay, Kira says she'd rather do this. I'm saying, by all means, you can do that. Do 409 times 100 divided by 896, you're going to get the same thing. This really ends up being the same thing. Okay, you know what? Because we were supposed to be already starting the review quiz 2, I'm going to fast forward. If you're not done figuring it out, it's going to end up being 45 point something, rounded off to 46%. So, Kiara, this is what they're saying. Out of the 7 billion people in the world, or let's just say they were talking about Americans, out of the 330 to 350 million Americans, they only surveyed 896, but we can be kind of confident that almost half of, less than half, their second toe is bigger than their big toe. No, but what I'm trying to tell you, Kiara, is it's not definite, but you're pretty sure. Yes.
Me?
Yes.
I was having a test on a quiz.
Friday's a test. Okay, ready?
Page.
Page. We are right now.
Yeah, but
Page. Your quiz starts right now. Literally, right now. Go.
What?
359. Thank you, Jaden. Jaden requests Miss Franklin answers. This is the best I can do, Jaden. It's got everything you need to know on one piece of paper, front and back.
Thank you so much.
Oh, can I have one?
I want one. We already went. When's the quiz?
Your last.
You guys can have.
Oh, yeah.
It's like every problem.
It's a ball.
So you know, like all the questions, like find, like proportions. So is this what we
Oh, thank you. Thank you.
Oh, all right.
Hey, y'all, break. Did
You guys have practice? Julia, Johnny, and Sawyer. I will try to download this,
I can give you a hole puncher. Anybody got a hole puncher?
or Bella can give it to Julia tonight.
Oh, it's like take your
Did
pencil.
you come in the back? No, that doesn't work. Mr. Frankie, you got a hole puncher?
Listen, Cameron, what this is instead of having all those examples in the book and having to leaf through the pages, and this is on one piece of paper, front and back, all the types of percent problems that you encounter, and it gives you a example of each one to follow. For instance, why are we talking? Shh. Example, you see a problem that says 24 is what percent of 32, and you're like, man, what do I do on that? Well, here's what you do. Now, I've tried to translate it for you from words into an equation by saying 24 is, okay, 24 equals what percent? Something over 100. So 24 compared to 32 is what over 100? 24 is what percent of 32? Or you could read that 24 is what part of 32? Because fractions and percents are the same. And the way they wrote it is, look, does that help you? Percent, we don't know. That's what we want to know. Something over 100 is the same as 24 over 32. Yes, Lauren.
So, I don't really understand, like, I know how to find it, I know what it is a decrease, and I'm kind of like.
Okay. All right, so number one, here was your original amount, $120. Hey, I want that. You take your mom to the store. Hey, I thought you said it was $120. Now it's $138. Well, yesterday it was. The price went up. There was an increase of $18. You put the 18 that went up over the original amount, Lauren. So find the difference in the original and the new price. Do you understand it's 18? Went up $18. Put that over your original. And now we're back to this. How much did it go up? 18 out of over 120 is the same as what over 100? Or, Lauren, you can just do, you can reduce it first to 9 over 60 or 3 over 20 and do 3 divided by 20. Wouldn't it be, look, if you reduce that 18 over 20, if you use your divisibility rules, you would have divided by 6 right away. And you get it down to 3 over 20. And then, if you get it down to 3 over 20, and you're like Jaden, and you're really into increasing your mental math skills, you're like, oh, 3 out of 20, 15%.
Yeah, Nathan.
Yeah.
Good job, Nathan.
Because 20 goes into 100 5 times, so you're counting by 5s. 5, 10, 15. Yes? No, I just did number 1. I said it's 15.
How did I get this? Why did you have?
Please stop talking.
Is it the same formula for
Here, 1. What was the original price? What's the new price? What's the difference?
Oh, I forgot that.
That's how much it went up. You got to find out how much it went up or down by finding the difference in the two prices. And you put it over the original.
So it's, yeah. No, yeah, what?
15% increase. Number 2, of course, is a decrease.
So when there's a decrease, do you still do the same thing?
Find the difference, put it over the original. So you're going to put 91 over 260. Yep. And that's how much it went down. Yeah.
Did you put the extra credit on that one?
I just added it to your test score. Yes.
What? Did you get all of them wrong? No, I know I did.
I'm gonna get like the sheets back.
Number 2, listen, if you did not put 91 over 260, start again.
Wait, what? What did you
You
say?
still on 1?
What did you say?
91
I kind of
Okay, listen. It is abundantly clear that you are approaching school and math in particular, and if this is true in math, you really get behind. You're approaching it as, what work do I have to do today? Tell me how to do it. Yay, mommy, look at me. I obeyed and I did did what I was supposed to do. If you don't start engaging your mind and thinking mathematically, it's always going to be hard, and you got to start doing it, right, Jaden? Think with me. The original price is $120, Mitchell, and now it's $138. So what percent did it go up? Why? Because if it went from 120 to 138, what's the difference in those two? 18. So it started at 120 and it went up 18. Well, what percent did it go up? You can do this, 18, set it equal to 100, because that literally means percent. So you'd have to do 1,800. How do you find out what's here? Divide by the other, because cross products have to be the same. Or, John, you're going to get the same answer if you just do this.
Yeah, that's fine. I don't know. I just,
Because what you'll get here is a decimal. And you change the decimal to a percent by going whoop. So this is your answer number 1, 15%. If you did it this way, you wouldn't have to change it to a percent. It would already be there. You would get 15. This way you got to change it to a percent. Yeah.
Do you do 75?
No, we're good.
We go about.
Number 4. 75 is 125% of what number? If I look at my handy-dandy cheat sheet, look at number 3 as I speak with you. Ready? It says 28 is 35% of what number? So here's what they wrote. Listen, do you see why they wrote 35 over 100?
Where's number 3?
Right here, other types of percent. Ladies and gentlemen, this will benefit everybody. We are working right now on number 4. Please, turn your attention at least to number 4. Number 4 asks, 75 is 125% of what number? That is similar to your cheat sheet number 3. It says 28 is 35% of what number? Do you see why they wrote 35 over 100 over on the right? Because what is 35%? 35 over 100. So 28 is 35%. 35 out of 100 is the same as 28 over something. 35%, 35 over 100 is the same thing as 28 over, how do they say it? We don't know. Something. That's our N or X or whatever. And how do you always solve these problems? By cross products must be equal. So, and their example on number 3 on your cheat sheet, 28 times 100 divided by 35. On number 4, it's going to end up being 125 or 7,500 divided by 125. Because you set up 125 over 100 equal to 75 over something. Number 4, 128 or 75 is 125%. I'll stop there. Do you understand that's 125%? Because over 100 literally means percent, per 100. Is the same as 75 over something. What is that something? Cross products. 7,500 divided by 125 will give me that something. Because the cross products have to equal. So 125 times whatever that is will give me 7,500. It has to equal 7,500.
When's the quiz?
Right now. Review quiz 2. Test is Friday. Yes.
Do you add sales tax or subtract it?
Listen, shh. When you go pay, say $5 for something, and they say, take the sales tax. Is it going to take off the price or add to? First of all, what do you get for the price of the shirt? No, it says it's marked down 50%.
Oh.
So you got $30?
Yeah.
Okay. So now you got to find 5% of 30.
Oh, I was saying 5% of 31.
I didn't even write it.
Even so, what's 30 times 0.05?
Yeah. Yeah, me too.
You had like $2 million. $15.
No, you gotta move, gotta put your decimal point. Cut again. Number 3. Who's done number 3 already? Okay, I'm gonna just pick you at random. See how many people got it right without asking the question. What'd you get for number 3? Total price of the shirt, Lorelei.
$32.
What'd you get?
$31.
So we got 3, how many different answers so far? 4?
33. 65.
30.5.
33.
All these answers and only 2 are correct. $31.50. Listen.
Oh, I
$1 off.
Come on.
Yes. Ready. Number 3. The shirt, it says, is $20 wholesale, but the retailer, we talked about those 2 words, I buy it wholesale. When you go to the store, you're paying retail price. So $20 gets marked up 50%. What's 50% of 20? So you have to add $10 to 20. So now your shirt is $30. The sales tax is, how do you write 5%? What? 0.05. When I multiply these,
For what?
I get $1.50. So sales tax gets added to the price. 31.
Okay.
Sold.
So you just add, you can still add that to your price. You don't, you just have to go back to 20. Why do you multiply the second one by the third?
Because when you buy the shirt at the store, it's $30, not 20. Yes. Case. Sure. Run out of time to ask questions. Now's the time to ask, not Friday or next Tuesday. Yes.
So for 7, 8, and 9, we put the board on the bottom for the amount of companies on it.
Exactly.
And then we just, okay, yeah.
The total number of spins, the total number always goes in the denominator. Now wait. Oh, wait. You have to set up a proportion. You're going to have two different fractions going on, Spencer. Spencer, how many spaces on that spinner? Listen, those of you that aren't listening, when you get to 7, 8, 9, you're not going to know what to do. How many spaces on that spinner?
8.
Okay, there's 8 total spaces on the spinner. Does that go in my denominator?
Yeah.
Okay, how many are blue?
4. Thing.
Yeah.
I don't have, okay, then,
Why, you colorblind?
no, I
mean, that's not a joke.
That's my joke.
Oh, okay. So 4 of them are blue. So 4 out of 8 on the spinner are blue. How many are red?
Yeah, 3.
3 out of 8 are red. And how many are yellow?
1 yellow.
1 out of 8 are yellow. Now wait, how many times are you going to spin it?
40.
Okay, so you have to set up
Oh, I like these type of.
proportions.
540.
If 4 out of 8 are blue, you're not paying attention. This is for 7, 8, and 9. If 4 out of the 8 spaces on the spinner are blue, and you spin it 40 times, regardless of Kiara's doubts, what should you expect the number of times it's going to land on blue? You should expect it's going to land on blue 20 times. Multiply both by 5. Does that mean it's definitely going to land on blue 20 times? No.
No.
You would have to do experimental probability to actually spin it 40 times and see if it does. But theoretically, you would expect it to land on there times 5 times 5 times. And think about it logically. Half the spaces are blue. So half your spins should be blue. 20 out of 40.
Wouldn't it be?
So wait, why are we doing that?
I didn't say.
Noah, we're creating equal fractions, proportions, 8 times 5.
Yeah.
How many purple dinosaurs are on food? You skipped the question. You skipped that one.
No.
Based on question 4, I'm gonna prove it. You walk around the moon.
Well, I know myself.
It was $20, we got marked up 50%. So now it costs $30 because it went from 20 to back 10.
If you need help, I'm helping with study.